Solve the equation z squared minus 6z plus 13 is 0, showing all working and giving your solutions in the form a plus bi. So I'm going to use the quadratic formula. So z is going to be minus b, so the opposite of b, so that's going to be 6 plus or minus the square root of b squared, so that's 36, take away 4 times 1 times 13, all over 2 lots of 1. So that's 6 plus or minus the square root of 36 take away 52 over 2, which is 6 plus or minus the square root of negative 16 over 2, which is 6 plus or minus 4i over 2, which gives us 3 plus or minus 2i. Factorize x cubed minus x squared minus x minus 15 into 3 linear factors and hence solve the equation x cubed minus x squared minus x minus 15 is 0. Now the fact that this is in a complex numbers question might tell you that this doesn't factorize to all real factors. And once again we can use the power of the calculator. It doesn't tell us to show all workings. So let's go to main, let's just clear everything. And what I'm going to do is I'm going to change from real into complex mode here. Action, transformation, factor, and then I'm going to put in this thing. So x cubed minus x squared minus x minus 15. So it gives me x minus 3 so that's a real factor, x plus 1 plus 2i, and I know the other one because it will be the conjugate, but let's just look at it, x plus 1 minus 2i. So if we have x minus 3, let's write this one as x minus negative 1 minus 2i, and this one as x minus negative 1 plus 2i equals 0 for the equation, giving us x is equal to 3, x is negative 1 take away 2i, and x is negative 1 plus 2i. And of course we'd expect the complex roots to come as a conjugate pair. Two roots of a quartic equation, remember that's a power 4 equation, are 1 minus 2i and 2 plus I. Find the equation. Now conjugate pairs are the way that roots of equations with real coefficients always come. So our roots are going to be 1 minus 2i and 1 plus 2i, 2 plus I and 2 minus I. So we've got conjugate pairs. So I have x minus 1 minus 2i, x minus 1 plus 2i, x minus 2 plus I, and x minus 2 minus I. Now if I expand here, I get x squared. Take away 1 minus 2ix. Take away 1 plus 2ix. And if you look at that, you can see the imaginary parts will cancel, and we just get minus 2x. Then we're going to get plus 1 minus 2i, 1 plus 2i. Difference of two squares, so that's going to be 1 squared. Take away 4i squared, so that's 1 plus 4, gives us 5. And the same sort of thing here is going to give us x squared. Take away 4x plus 5. So if I just do x squared times everything here, I get x to the 4 minus 4x cubed plus 5x squared. Then the minus 2x times everything, so that's going to give me minus 2x cubed plus 8x squared, take away 10x, and then with the plus 5 I'm getting 5x squareds, take away 20x's, add 25, so that's x to the 4, and take away 6x cubed, add 18x squareds, take away 30x's, add 25. So our equation must have been x to the 4 minus 6x cubed plus 18x squared minus 30x plus 25 is equal to 0.